Hello, and welcome to my demonstration of assignment 5. Let's take a look at the assignment. The task of this assignment is to create a star topology network, the sub-1 GHz application or 2.4 GHz application. We had to do the pre-assignments, the LPSTK stack, the sensor and collector project 0, no sensor terminal required or available. You'll not need a booster pack for this assignment. We're going to be using the LPSTK sensors, use the HDC, so basically just use the sensors on the LPSTK. So let's take a look at the first thing we had to do, which was this LPSTK TI stack. So in this project, I imported the collector sample project, and I added in this code here, and also this code here, or replaced this code and added in this code here. This basically lets the collector node to print out the data for the LPSTK sensors. So that's one of the things I had to do to my collector code. So let's keep talking about the collector code before I move on. So we can do this in one shoot. So let me go up to my collector. Where is it? Collector code for assignment 5. So we started with the collector project from the Resource Explorer. We imported that, we made a copy of it. And we made the modification to the collector code to the application. And inside the collector folder, we added we added this line of code. And the other thing we did to the collector before we move on is, I believe it's in the adding a new sensor project. In this adding a new sensor project, we went through and we added, we edited this file according to this TI stack, adding a new sensor project. We added this generic sensor request, generic sensor, all the stuff for the generic sensor. And this adding a new sensor tutorial really shows you how to count the button presses, right? Because on this assignment, our goal is to display data from the sensor node on the collector terminal, humidity, temperature, and/or light. Humidity, temperature, and/or light. Button 2 counts, and the button press 2 counts. So the TI 15.4 stack adding a new sensor. This shows you how to add a generic sensor that is just a counter, and then they have you set up the collector. So we've completed all of these steps to basically collect the generic sensor, which is going to be our button presses. So the collector is set up in this way. That's the only changes I've made to the collector node. The collector node. All we've done is we've added a spot to hold and display the sensor data and hold and display this generic sensor. That's all we've done to the collector. And that is shown here on the collector. So we'll go ahead and build this, and we may as well program this. Build and program to see that it is working. Okay, and then let me bring up the setup here. Make this a little bit bigger. Oops. Can I Control Z that? No. Make this bigger. There we go. Okay, so let's talk about the setup. The CC135 development board here is going to be my collector node, this big guy right here. Here's the LPSTK. Now I have the JTAG being used here. I'm going to go ahead and unplug that one. right? Because, and we'll unplug the UART. So, are we in focus? Is that focused? I think it's kind of in focus. Seems like it's a little bit out of focus. Good enough. Okay, so let me get a pen here. All this stuff over here, this is basically like the debugger / programmer side of the board. That's the CC135. This is going to be the collector node. So we're running it, ignoring all of this crap. But if we want to program it with our collector code, we actually need to take our little connectors here and plug them in to connect this CC135 to the programmer and debugger, because we only have one programmer and debugger and we have two CC135s. So we'll get all this plugged in. There's a couple more. Am I still recording? I do have an Arduino Uno out here. I will talk about that in just a little bit, but for now we're not using it. Just get it out of the way. Everything is plugged in on here. Good. So I'm gonna lower the preview. So now we're hooked up to the. Oh my goodness! What just happened? It's upside down now. Pause it. And we're back. Okay, so now we're hooked up to the programmer debugger. I'm just going to hit this debug button up here, and it's going to put it on my CC135 here, this one. Not connected. Oops, I unplugged it. Let me plug it back in. So this right here wasn't plugged in. It's plugged in now. So now we can click retry. Should be getting connected. And I think that worked. So we've built and we've connected the collector, CC135 collector. Okay, very good. Now we're just going to turn this off. Leave debugging mode. I'm actually going to make the preview larger now, and I'll show you what I'm doing here. So I'm going to disconnect the board, and I'm just going to rip out all of these connectors except for the ground, 5 volt and 3 volt. Oh man, can we get in focus? Can't tell if that's in focus. Can I make this full screen? Yeah, so you can see there the ground, 5 volt and 3 volt are still jumped across. So that's giving power to the CC135 right there. Okay, so now this is where the Arduino Uno is coming in. So the Arduino Uno, all I'm doing here is I've programmed the Uno with a blank sketch, and I've connected the TX and RX here. TX and RX. Can I get that in focus? This is hard. Yeah, the TX and RX are being used, and they're just getting hooked up to. Get in focus. Yeah. They're getting hooked up to the CC135, this guy, on this side, like that. Okay, so now what this is going to let me do is I'm going to get in focus. Man, that autofocus is annoying. I'm going to lower the preview, and I'm going to close these guys because these are what I'm about to open again, but I'm going to close them and show you how I'm opening them. Okay, and then we're going to come over here. We're going to open up a terminal, and there is the terminal that I'm going to be using as PuTTY, and we're also going to be opening up Device Manager. And we can see on the device manager that I had to unplug my mouse because I'm using too many USB ports. We have the Arduino Uno hooked up. So what I can do with this is I can open up on COM14. COM14, we got 115/200. Open it. It's blank. That's because we need to plug this in. So we'll plug that in. It's going to start up. And oops, I had this window in the way, but you can see now TI Collector is loaded and it's waiting. So we're going to minimize this for now, and we're going to talk about the sensor. So the sensor, much in the same way as the collector, the sensor, what we did was we followed the instructions for loading the sensor. So this 15.4 stack, they want you to do over-the-air download from the Simple Link starter app. Now, what this is going to do is this is going to load the DMM example, this DMM sensor example. So this is using direct memory access. It's using all sorts of features that are not a part of this project. So we can't, this can't be turned in as my work, basically. So what I had to do was I actually had to get the sensor project. This is going to give me a blank sensor project. Is it in this one? The sensor. CC135 CCS. This guy. So we import this one, and I'll go ahead and do that. Do I already have it imported? I might already have it. I don't. Okay, so we'll import this guy. And this is going to give you a sensor for the CC135 to launch XL. And then we're going to open this, and what's inside here, we are having a, just a blank sensor, right? And I believe this is what they want you to do for the adding a generic sensor. They want you to get the sensor, the sensor your board launch XL. Yeah, so select the sensor project when importing. So we're importing just the regular sensor project. So that's what I did to add the button feature. So I add all this code from the adding a new sensor to just the generic, to the sensor template, and developed it so that now the button click is working. All right, but this does not include the LPSTK sensors. So once I did this, we're basically having just the CC135, and it can do the button clicks. All right. So like if I open up this sysconfig file, you'll see that basically everything is working, but we don't have access to the LPSTK sensors. And I'll show how I got those working as well. So the collector is ready to take the LPSTK input, but the LPSTK isn't transmitting them. It's only transmitting the button clicks. This guy right here, it's only transmitting the button clicks. So, another thing to note is so I opened the sensor.sysconfig. You'll see that it's basically blank. There's no ADC. There's no I2C being used. There's nothing really being used. The UART's being used. That's about it. And if we go to the hardware, we're only having the CC135 here. Okay, so we'll close this. The other thing to note is that this TI stack, how did it get to this window? That's weird. That full screen. The other thing to note is adding this new sensor tutorial. It shows you how to get the generic, couple of things to note. So this generic increment, where's the increment? this increment right here. This is being placed inside the if keys is equal to the left button, and the project was asking for the button 2, and the button 2 is going to be the right button. Do I have that open? I thought I had that open. Give me one moment. The button 2 is going to be the right button. Where is it? This guy. Move this up. Make it full screen. Full screen. Okay. So let's pause it for a second. So button 2 is I'll hold up the board. The right button is button 2, and I know that because I looked at the board. So I just took a look at it, looked real closely at the right button. Come on, get into focus. Focus, please. There we go, button 2. Right there on the right button. So, anyways, lower that back down. We can close this, it's fine. So instead of the left button, basically I kept this the same, but I put the right button here, and I put what was on the right button code, I put that on the left button, because the right button code inside, like right above this section inside Code Composer Studio, the right button code actually disconnects or disassociates the sensor from the network. So I made the left button disassociate the sensor, and the right button is now doing all of this. So I just swapped them out. And I think that's all the changes I made. Yeah, that's everything to get the button presses working. Now the final step is to actually get the LPSTK to transmit to the collector node the sensor values. So like this works, and it compiles and it runs, and then I can connect the LPSTK to the network, to the collector, the sensor to the collector, and the button presses transmit, but the sensor values all stay at 0. So how do we get the sensor values to work? So what I did is I had to take a look at the DMM project. This is from the out-of-box experience where you over-the-air download this. Now this DMM project has so many things going that we're not going to be using. So if I open up this DMM project and look at the sysconfig, it's using DMM, it's using BLE, it's using all sorts of stuff. And then over on the hardware, we have this LPSTK sensor. So first of all, to get access, what I did is I went down to my sensor that has the button presses working. I opened up my sysconfig as a text file, open with generic text, and I opened the DMM as generic text, open with generic text. And then the DMM, it has here the LPSTK sensors, booster pack LPSTK sensors. So I copied this line of code, I pasted it into my sensors project, and then it turned it into this, which is a little bit different. I'm pretty sure after I ran it, it converted it and rewrote it as that. But you have the LPSTK sensors. So the result, I can close down these text editors now. The result of doing that is that now in the sysconfig, when I open it with the GUI, the sysconfig over on the hardware, now we have the LPSTK sensors. So like if I open the sensor project, that's the unmodified default one, we saw that it was having nothing. It was just having the CC135. CC135. There's no, so now we have the LPSTK sensors included. So the other thing the other thing I did was I went back over to the software and no, before I went over to the software, the other thing I did was I went up to application on the DMM application. We had this LPSTK folder. So I basically right-click copy, and I pasted it into my application folder. And then I pasted it in here and then tried to build it, and there was a whole bunch of errors. And basically that's because I had to go through this DMM and, on the GPIO, I had to get this opt interrupt, HDC interrupt, SPI interrupt, blue LED, and add those into my GPIO. And then it's complaining, oh, the I2C is missing. So then I added in the I2C. You can see I can select the Launchpad LPSTK sensor. And then what else did I add in? But just basically go through one at a time and add in the things that I need. Oh, it turns out I did not include the SPI. I'm not using the SPI here. So I didn't bring in the SPI interrupt. And what this let me do is then now the LPSTK is now able to be built just by copying and pasting it into here. LPSTK can build. But I ran into another error where this LPSTK is basically in the sensors code on line 375. It threw an error. 370. Yeah. So you have all of these calls to HDC 210, get hum, get temp, get lux. It says these are all like not declared, and then so in order to figure out where those were defined, what I had to do was I had to basically go up to the DMM and because I couldn't really find where those function definitions were. But what I did was I opened it with File Explorer, gave it a right click, open with Visual Studio Code. Visual Studio Code, you can just come over here into the directory. Let me make this a little bit smaller. Come down here in the directory and find in folder, and I did a search for HDC 210 close, and then it said it was in this sale folder. And I was like, oh, well, that's interesting. It's in the sale folder. So I come back here, scroll down, and outside of the applications folder, there's the sale folder. So I just copied the sale folder and I pasted it into my project. So now my project has the sale folder, and the sale folder has all of these header files and function definition files. So once I pasted it in there, then this thing built. And so I'm like, well, this is the first time it's built with me trying to basically transfer over all that stuff. So I'll go ahead and close everything down and show you that it builds. Well, I didn't modify anything, so I'm going to say no to that. Close it all down and build the project. Good grief, this is 24 minutes. Okay, so we built the project and it worked. Now let's talk about connecting the LPSTK to that programmer debugger. So we are taking the JTAG and we're connecting that. We're connecting that up to this guy right here. And then we're taking the UART serial communication and we're connecting it to the debugger programmer like that. So now the XDS debugger programmer chips are hooked up to the LPSTK instead of my CC135 here. They're hooked up to this CC135. So with that out of the way, we can now program the LPSTK here. And so we're now ready to get started. But I think one final note: why does this work? Why am I able to just like import LPSTK header files and program files? Well, basically the sensor project. If I leave my sensor assignment 5, if I leave this project, I look at just the imported sensor project. If we look inside the sensor project, we look in the sensor code here, and we take a look at I don't know, maybe the sensor. What's a good example? Maybe sensor C. I don't know if it's actually in here. It's in one of these folders. And if I do a Control F and I search for LPSTK, LPSTK. They're saying if define LPSTK. So if this is defined, then we're going to be doing all this stuff. So yeah, this is an important step that I might have almost forgot to mention. In order to get these to run, this if define LPSTK, what I had to do was on my developed code, the final trick to get it working is I had to right click on it, come down to properties, and then come down to these predefined symbols and add in this LPSTK. So when I add that in and apply and close, now it's gonna build. On this one, come down to properties. There's no LPSTK defined in here, so that's not gonna have these lines of code where it says LPSTK. It's not gonna run. So we've done it, we have it. Let's take a look at it. Sounds pretty good to me. We'll close this down. We're going to minimize that. We'll bring back our collector, make sure that terminal is still alive. So this again is running out of the Arduino here. That's the COM port on the Arduino. And then on the device manager, we have the XDS COM port on COM12. So we're going to open up another PuTTY terminal. PuTTY. $12 115 open. And it's a little bit bugged out, but as soon as I restart this, all I'm doing is I'm plugging the JTAG. That is disconnecting power. And actually, I'm going to down here make this preview a little bit larger. We can lift these guys up. And we can bring this one over here. I like that. That looks good. And we can make this one larger. Okay, so the COM12 is looking a little bit messed up, but if I reconnect this JTAG now, you can see that it's all cleaned up, and it says TI sensor right there, and it's a live terminal. We have the TI collector, it's a live terminal. So we're going to open up, form a network, and open it up, and you can see it's now blinking over here, waiting for things to join. And it looks like this guy's already connected, which, oh, it says status rejoined. I guess it has memory to join. Well, if I go to network, disassociate, you can see down here now it says it's disassociated. That was weird. That's interesting. I wasn't expecting it to auto reconnect like that. Then if I clicked associate, You can see now it's joined. Down here we're having the temp, humidity, the light. For the light, what I can do is I can kind of cover it up like that. You can see it goes down to 2. And the humidity goes up because I guess my palms are a little bit sweaty. Humidity's going way up. Wow. Take my hands away. You can see the humidity go back down and the light come back up. Okay. Yeah, the humidity goes. Okay, that's a little bit embarrassing. What else? Oh yes, so the final thing is if I push on here the right button on the LPSTK, I push the right button, the generic count is incrementing, and you can see it increments on the collector. So the last thing I wanted to show real quick was the point of all this is, you know, now we have the LPSTK, and you know, I can take it over here. There's no wire connection. This is running on battery, and it's wirelessly connected to the collector node. So I can take it over here. Right. And we're getting the light sensor. Cover that up, make it dark. The light goes down. And then if I click the right button, generic count goes up. This is on the collector node. So this is, watch, I'm gonna press, I'll do 2 presses, 1, 2, and it goes up. Just like that. So that was the trouble of all of this. You can see the JTAG cable is disconnected. So that's the end of this video. Thank you for watching.